what are we going to look at here? Let me zoom in on this. So ultimately, we are if session one seemed like a lot, we are going to go much slower and in a lot of detail and really get to the core of what everybody wants to learn here. So how we're going to do that is we're going to take this lecture and really learn the building blocks of analyzing Web3 data, blockchain data, using one of these data providers. And to walk through an example, what we're going to do is we're going to look at an NFT project. In particular, I saw pudgy penguins have been extremely hot lately. I know their floor price has gone astronomical. So I figured, hey, why not take a closer look at that NFT collection, and we'll build our skills by looking at something that's sort of trending here. So in addition to that, I'm also going to be looking at sort of what an NFT smart contract is. What is this data we're pulling? I'm going to show you how to sort of use LLMs or ChatGPT to accelerate your learning, to really rely on it to help you get better faster. I'll be honest, I know SQL extremely well. I've been doing it for over 2 years, use it daily. I still use ChatGPT instead of pulling up the documentation sometimes and reading and trying to find what I need to do. I'll just type something up to ChatGPT, it gives me the answer. It's much more efficient. At this point, I think if you are not using some type of AI assistant, you're kind of, I don't want to say you're falling behind, but it's just a free resource there that'll make you a better programmer faster. So definitely recommend using it. And I'm going to highlight a little bit just on how us looking at this data and to be a Web3 analyst, you really are learning the skills to become an on-chain detective. You really have to know where to look and where to find things. And I'm going to show you guys kind of from scratch what I do to sort of find these things on chain to start analyzing. So if you're becoming a Web3 analyst, you're also at the same time really becoming an on-chain detective. So it's also a cooler term, I think. So, all right, no questions, then I'm going to go ahead and get started. And please speak up if there's any audio issues, if there's any screen issues, anything going on that is from a technical standpoint that I need to address right away. All right, introduction. So what are we going to do today? We're going to look at the basics of SQL. We're going to really start with what are all these elements that we're using to query the data, and I'm going to go step by step. So if you've been doing this for a while, perfect. This is just going to be a repeat and should just be served to be like a reminder and rehash and relearn everything that you do know. And if you don't know it, then perfect. That's kind of the target audience here. This is a beginner class, so we don't expect anybody to know anything here. But I did ask during the last class to everybody to go take an intro to SQL course to just get freshened up to it a little bit. So this will sort of be building on that. If you were not able to do that homework, then no worries. It's again, we're going to go step by step here. So take your time, watch the recording if things went a little too fast and you need to slow it down a little bit. And last thing I'll say is you don't have to follow along here, and I actually recommend that you don't. I think you might get stuck on one thing and then I'm going to be going too fast and you're going to get lost. So I really recommend just following along, paying attention, and in the future, there's going to be a homework assignment after this class. I'll go over it where I'm going to ask you to basically do the exact same thing I'm doing here, but for a different NFT collection. And then at that point in time, you reference the recording and you put it on the slow mode on the recording to kind of watch what I'm doing again. So let's get into it. I think you saw last time how I gave you a quick look into what a query looks like, and they're all structured very similar. They all start with a select statement, and then what you have here is select what columns do I want to select. And one of the most common things you're going to see is this asterisk. Well, what is that? And I use it all the time. That's just saying I don't want to pick any particular columns from a table. I think of an Excel table. I don't want to pick this column and that column. I want them all, but I don't want to write them all out. That's very laborious task. So that's SQL has this nice little feature that you can put in, which is an asterisk. Just give me everything in the table. Give me all the columns. And then we got to take our from statement here, and this is saying, okay, what table do we pull? So today we're going to be pulling from the easy NFT mints. And this is coming back to the last class, we walked through like kind of raw data. We talked about these easy models that have been created that make it really simple for our job. So we're going to work on these easy tables because this is sort of definitely where you want to start as a beginner. And then in the next class, we'll look at raw data, which is more intermediate. So let's start by looking at these tables. So we're working with Ethereum and we want to look at NFTs. And awesome, they have 3 easy NFT tables here that they've already pre-built for us to look at. And if we look at easy NFT mints, we can look at the documentation. And I definitely think we should go through the motions here. But really what this is showing is, once it loads, scroll down. Okay, here we go. It's in a whole, it's showing us all the mints from NFT collections, and it has all these columns: block timestamp, transaction hash, the NFT project that was minted, the project name. So list goes on. You can see what all of these mean here. Very useful information. So this is the table that we're going to be using. I recommend sort of understanding what each of these columns are and what we're going to use. We'll use maybe about a fourth of them today, so you don't need to know all of them. A lot of it's just additional information for other analyses that you'd want to perform in the future. So for us, we are going to just grab this full table. And quick thing with flip side is there's a little kind of cheat code where if you click the table and then you click push over, well, now I hit it twice, but it'll send it over. Otherwise, you have to basically copy paste it or type it out. So it's really efficient, helps you kind of program faster. So just a little cheat code there. All right, so far what we have is select every column from this easy NFT mints table. And if I hit run, we learned last time that this would query everything. And usually we don't want to do that. And I'm not going to do it here because I don't want it to take forever to load. So moving to the next element that we're going to learn, we're going to use limits here. And like I said, really limit when you're starting a program, always use it. It's a safeguard to prevent you from, pulling too much data and waiting 10 minutes or however long it takes. But yeah, okay. In long form, limit is, hey, just return X number of rows. So instead of querying millions and millions of rows and returning that, just return 10 of them for me. So if I go ahead and run this, it should query all the columns for 10 rows. All right, there we go. And here we go. Yep, we see 10 rows and we see every column that's listed in this table here. That's NFT mint. And then project name. So yeah, these are all different NFT projects here. Okay, pretty cool. Yeah, we just queried this table and pulled some interesting data that we wanted to see. Now, let's talk about aliasing. So if we want to, instead of pulling every table, we only want to pull, let's find an interesting one though. We just want to pull project name. So we don't care about any of this other data in here. We just want to know project name. And actually, this is named pretty well, and it's clear enough, and it's shorthand. So a lot of times we won't use aliasing. So in this case, I will. I'll just say we are going to use it. And what this is basically just renaming that column to something else that you want. And this is not good habits, but if I just named it PN for shorthand, it would be a project name. I don't think I'm going to do that. I don't think that's a good habit, but I'll just call it project. I think that's clear enough. So you can rename columns, and we'll call it project. And then if we run this, it should label that column just project. So here we have this opportunity to sort of edit this table to be however we want to customize it. And you also notice how I went from that pull all columns to just pull this one column, and that's all we have here. All right, so far we've looked at the asterisk, limit, aliasing, And then now let's look at distinct. So when I pulled this select project name from this table in limit 10, I see several rows that are duplicates. And that's fine. That's the nature of the data that we pulled. But say we only want unique project names to be listed. A tool that we can use is called distinct. And what this will do is says, hey, pull this column, but only give me distinct values within that row. So if I run this, then we shouldn't have any duplicates. There we go. Now we got 10 unique NFT project names. All right, and I'm running through all these because they're very core SQL tools that we'll use. But I'll then be jumping to examples where we're going to be using them in an actual action. So if it's not completely clear, either say something now, ask me to explain a little more, or just know we're going to go into it into more detail as well in future examples. All right, so far we've pulled 10 unique project names. We gave it a new name here. And next we're going to look at order by. And what this is doing is basically, think of an Excel, you can sort a column by a value or alphabetically. That's all that this is here. So if we do order by, I'm just real quick going to run this so you can see it, order by one. This is saying column one, but it's shorthand. If you really wanted to do it the long way, and if this makes more sense to you, order by this column. So we can say either order by this column, or there's only one column, so we can say column one. If there were two columns, we could say column two. Oh, I renamed it. Project. Oops. Let's see. Line one positions here. What am I missing here? Project. All right, but this happens here. So you're kind of wondering, what happened here? It's telling me there's an error on line one. Select distinct project names project. Transfer by limit 10. Let's see if it runs for one. Sometimes there's different syntaxes here. Might be ordering. You guys are watching troubleshooting live. Oh, what am I missing here? Let's see if this one runs. I just did this a second ago. Um, all right, we might have to come back to this. I think I'm missing something silly here. I just had this run previously, so I don't know why it's not running now. Let's just try something new. Maybe I just need a new query. The flip side might be running a little slow right now. Or it could be my internet connection. Alright, looks like I'm still on. Alright, let's see if this will run. Alright, yeah, I thought my code was right. So it looks like Flipside maybe just got a little stuck. So what I did is I just created a new query and refreshed the page. But let's see if we can go back now and get back to the introduction here. There we go. All right. All right, we're live. All right, so what this did is it basically just ordered the project name alphabetically. And what you can do is say ascending. So if you want an alphabetical order from A to Z, or you want it reverse, Z to A, you could do descending. Um, yeah, so if we run that, it should flip it. All right. Hopefully, I went through that sort of slow enough. If anybody has any questions, usually this order by, you're going to use it with time series. So like dates, you want to order by dates. You want to order by values. You can see it's a little strange here, ordering by emojis. It's not maybe not the best example, but gives you a rough idea that you can order any column descending or ascending. All right. Any questions before I move on to our first real example looking at this NFT project? And I don't think I've been tracking the comments here. All right. Yeah, Juke, if you do me a solid, let me know if I'm missing any comments here. I know you um, said you might be busy at the beginning of this meeting, but for some reason I don't see these comments as they're going on. So
Yeah, Tim, I think we could answer Tolulupe's question. So when we do select everything and we don't have any conditions or the query is not time bound, he want they want to know what rows will be pulled. So I think it's random, but basically if you time bound your query so that it selects everything from today, you'll get the data from today. But if you just do select everything, limit 10, like your first query, um, is the result random as to the 10 rows that are selected? I'm not really sure, but maybe you know. Thank you.
yeah, no, it is a good question, and so 2 points from it. I'm actually not sure, and mainly, I don't think it's ever something you actually are going to use in reality. Um, I've never actually pulled just 10 unless I was just testing something to look at it, or in a real analysis. It's not something that you'll actually be doing. But yeah, I'm not sure if it is random. It kind of seems like it. Actually, let me. So here I select all from here. You can see it's taking 40 seconds to run. It'll take a while, and I might just kill it so it doesn't run forever. But one thing that you can do, and I'm going a little bit deep here, is you can order by let's do like mint date, the time that something was minted. And let's go ascending. So let's find the very first, and then limit 10. So this year, since we are putting that order, it's not random. So where it's actually going to just pull the first 10 mints that ever minted. Let's cancel that. And let's, whoops, sorry, I got too many queries here. I gotta comment this out. And a tip while I'm commenting, control / is a quick way to comment everything out. All right, so let's run this. See what it gives us. Okay, yeah, reading. Okay, this shows us from Flipside's data set. We are saying select all columns from the easy mints, order by block time. So we're grabbing everything. Let's order it by block time. So it's going to take an ascending block time order, and it's starting from the very first block time to the last. And then we're saying, okay, now that we've ordered it, just limit it by 10. So it's grabbing the top 10. So here we see the first 10 NFTs that were ever minted according to Flipside's data set. So pretty interesting data what you can do with limits. But usually this is the only way I use like sort of limits. I won't use limit just on its own unless I'm learning or testing or showing stuff like that. So there definitely are use cases for limit, um, but if you're just using limit, I think it's random. All right. And then, yeah, someone was noting capitalization. So luckily, and you're gonna notice I pick up some very poor habits. I did not learn programming traditionally from, I kind of was self-taught. And I think the traditional programming, a good habit, I'll call it, is to capitalize, select from, limit, order by, and then to keep your column names lowercase. Uh, you might have to correct me on that. Someone who's more traditionally trained, there are specific ways you're supposed to do it, but luckily, SQL is not capitalization dependent. So you can mix up, you know, capitals and lowercase, and it'll be totally fine. It'll know what you're doing. Like here, you see I have lowercase. Here, I have uppercase. So not an issue. It's actually really beneficial for learning out, where I know other programming languages, you have to keep the same format. So even spacing, if I put 10 tabs here and I run this, it's going to give me the same result. So it's very forgiving for an entry-level programmer, someone who's learning. Should probably have better habits, but yeah, we'll save that discussion for another day. All right, it looks like you guys, when I was running into some issues, were trying to help. So I got this chat open on the side now. I'm able to see everything, so I appreciate it, everyone. All right, we actually got a really good question here. How were the data sets curated, validated? That is a fantastic question and something you should always be aware of. I've ran into scenarios where I've queried a model on Flipside, and I've queried a model on Nansen, and I've queried a model on Dune, and I'm getting different results. And I wish I could tell you there was an easy way to get to the bottom of these, but a lot of times it involves opening up the model and understanding how they're pulling their data. And they're just like anything else in programming, there's a lot of different methods to solving what you're trying to solve, and different platforms might solve it in different ways. Now, one thing that's fantastic is there's a lot of good discussions within these discords when data is not matching someone else's data. And I know the Flipside team's really good at it. I know the Dune team's really good at it, of looking into it and seeing, oh, why is there a discrepancy? And a lot of times it's like, oh, we made this assumption when we built the model. We made that assumption. End of the day, very good to be conscious of that. Nobody is ever going to have completely perfect data across everything. I think you have to make assumptions, and that's where looking at the documentation and understanding what assumptions were made when building out this data is important. Especially if you're doing this for work, you're doing it for investment purposes, you really want to know. And I'm going down a rabbit hole here, but to give you a very specific example, we were working with a client where we needed to capture certain volumes of, I'll call it an asset. So let's just say um, some token that's trading, let's say it's Link, and they wanted to know the volume on all decentralized exchanges. It's like, okay, that's something we can do. And as we saw in the last class, if we want to look at swaps, we could go to this DeFi, we could go to this easy DEX swaps, and I would say, okay, show me all of the volume from this token by all these DEXs. Well, technically, if you read the documentation, and every platform will be like this, it does not include every single DEX in existence. So I'll say 98% of volume goes through, the top 10 decentralized exchanges. And sorry, let me explain these acronyms I'm using. A DEX is a decentralized exchange. So think of like Uniswap or an aggregator like 1inch. So in reality, in this here, we can see in the documentation is it's saying it covers all swaps from Sushi, Uniswap, Curve, Synthetics. So it covers all these, and this is going to cover most of it, but it is not every single swap because there's these really, really small decentralized exchanges that don't get a lot of volume, but they still have liquidity for these assets and they are trading them. So it's important to know that, hey, it's good enough for our client. When we talked to our client, we said, hey, we can cover what we see as 98% of the volume on chain. And they said that's good enough. That gives them enough information for what the intent of the request was. So really good question. And that's something you're going to run into constantly is how good is this data? All right. I'm looking at the clock. I gotta I gotta move. We have three examples to run through here, but keep the questions coming. These are very good questions. Um, I appreciate it. All right, what are we looking at now? Okay, we're gonna analyze pudgy penguins. We're gonna look at a couple different things here, and this is what our answer is. So let's go ahead and hide that. Da, 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 da. All right, we're gonna say, hey, how many tokens were minted? So basically, that's saying how many tokens in the collection have been minted. We're gonna look at how many wallets or users have minted. Now, when analyzing on-chain data, we use interchangeably the term wallets and users. We think we can see that one unique wallet has minted a token, and so we associate that with one user. Now, as you get more into things, you do learn that multiple users or one user usually owns up to a dozen wallets. So you can't really say that one wallet is one unique user, but it's really the best we can do a lot of the times with the data that we have. So if you see number of users that minted, that usually means number of wallets and vice versa. All right, we'll also look at how much ETH revenue is generated. So Pudgy Penguins minted, and there was a mint cost, and yeah, how much did the team make by minting out however many tokens we're going to find were minted? And we're also going to see how much USD value that was at the time. And then we're going to look at transaction fees that were paid. So this is the gas fee, the gas cost that I think we showed when I looked at the block explorer in session one. I think you'll be surprised that a lot of times during NFT mints, especially ones that occurred in 2021, people were paying a lot in gas and almost more in gas than what they were paying to mint. And yeah, it was kind of a messy situation. People called it gas wars back then, but it was a price to transact on Ethereum when demand is high. So, all right, let's use everything we just learned in that introduction tab and apply it to finding this type of data here. So we start with our select statement. And what we're going to go here is we want to know how many tokens were minted. Okay, let's think here. Where's our table that we're using? We want to use easy NFT mints. So we pull this up, and I'm going to put it down here so that we know what table we're using. Okay, how can we find the total tokens that were minted? I'm going to look through the table here. So if you click on this, it brings up this little mini window to view. Insert timestamp, log ID, amount USD. I'm going to keep looking. Token ID. So this is where maybe having a little bit of knowledge of like NFTs and hey, what is an NFT? What is it? An NFT is a unique token, and they call it a non-fungible token. So there is a unique token ID for each token that is minted. So if we think about that, we think, okay, if I just count the number of unique token IDs, then I can figure out the total number of tokens that were minted. So what we're going to do there is we're going to say token ID. I'm going to bring that over. All right. And that doesn't get us how many yet. This is just going to show us all the token IDs from this here. So there's more steps we want to take here. So we're saying, hey, show me the token ID column from easy mints. And then here's a where statement. This is a filtering statement. We need to say, we're analyzing pudgy penguins from all the NFT mints and all of Ethereum. How do I find just pudgy penguins? So we're going to put a where statement. And what you need to define a specific collection is each collection has its own unique NFT smart contract address. And what this is here is NFT address. All right. So if you're familiar with NFTs, Azuki, they have their own NFT address, Pudgy Penguins, Bored Ape Yacht Club, all those are very unique. So this filter here allows you to look at them singularly. And so what do we have to do here? We have to go find what that address is. And this is where sort of the very, very beginning stages of being an on-chain detective is how do I find this? And I think I spend a lot of time just researching how to find data as much as I spend time in this SQL code here. So what I do normally is I'll go to OpenSea and I'll type in pudgy. Oh, typed that wrong. It knows what I want. That's kind of weird. All right, pudgy penguins. Let's get that one. See if it'll load. There we are. Okay. Um, and just one note is you got to be careful and sort of just Googling stuff and searching. There's a lot of scams out there. This is the real one. I could see that there's been a lot of volume. The floor price it passes the initial test for me. I'm not buying or transacting anything, so I'm not overly cautious. But just take a glance, take a moment, make sure it's not a scam, make sure it's the real one. So, a couple ways we can do this here. We got to find the NFT contract. We can go here and we can say view on Etherscan. Now we're back at the block explorer and we have the contract address for Pudgy Penguins. And if we check here, the Pudgy Penguins, nice, they have it named. So I can take this, bring it over to flip side and put it there. And I'm gonna show you a couple other ways. This is just got sort of playing around. Okay, let me click one of these. I see up here, there's an address. This is the smart contract address for Pudgy Penguin, so you could take it from there as well. If I scroll down, let's look at some details. Contract address, perfect. We got a contract address there. And then lastly, if we really want to get into the details, this is showing all transactions. And if you click here, it'll show you the transaction details in the block explorer. And we can see recently, one was bought for 9.4 ETH from OpenSea. Here we go. Here we go. We got Pudgy Penguins. All right, so 4 different ways to find it from OpenSea. I'm sure if you were just on, excuse me, just Block Explorer, Pudgy Penguins. A little bit harder to find here, but maybe this would be it. Anyways, a couple different ways to find it. You got to get good at sort of learning where to find things. So we have it here. And I'm going to add a little note here is this NFT address is labeled as a text. So we then have to input the contract address in the same data type. So we also have to do it as a text. And how we do that in Flipside is just putting these single little quotation marks right here. And again, a little nuance is it has to match perfectly. So if you make something a text with these quotation marks, capitalization does begin to matter here. And one thing that happens is the NFT addresses are stored in Flipside as all lowercase. So if I were to run this, we have a mix of uppercase and lowercase. It would show nothing because nothing would match here. So one thing just to safeguard yourselves is always put, when you're inputting a contract address, a transaction hash, you never know if what you're copying is going to be a variation of uppercase and lowercase. So put in this hey lower function. This will make all of these text values lowercase. Maybe most of the time you don't need it, but if you always put this in here, it'll prevent you from running into an error. And actually, I'm going to run this error so you guys can see how kind of difficult it is to figure out, hey, what's going on? Why isn't this running? I remember when I started out, I was hitting this and I was like, what? I don't get it. This is the contract address. This is everything. So it doesn't really tell you anything. Nothing's wrong because everything's right. But this NFT address, which is in lowercase, does not match this because this is a mix of uppercase. So um, yeah, let's see what happens now. All right. So what this pulled is every token ID that was minted. And a token ID can only be minted once, so there won't be duplicates. But, if we wanted, if we didn't know that, we could do distinct token ID, and we'll see that it'll give us the exact same. All right, so we see 8,888 rows. That is how many unique token IDs there are. So if we want to say how many tokens were minted, that's our result. well, that's how many rows we have actually. It's showing us all the token IDs. But what if we want to answer that question within our code or within our output within one row? We're going to have to use what's called an aggregate function using a group by. So this is where you go from looking at tables of data to really analyzing data and getting some really, really good information that outputs concise outputs, yeah, that basically you can then digest really simply. All right, so what we're going to do here is we are going to do select count. And what this is doing, total NFTs into. All right, what did I do here? So I took our column that was just outputting all the token IDs. Now I'm saying, hey, count how many token IDs there are and rename it, oh, forgot, as total NFT tokens minted. And then running through the rest of this from this easy tables that we're using, and then filter where the NFT address is equal to the Pudgy Penguins one. So if I run this, it should output 8,888 in this first row, and the column should be called total NFTs minted. All right, there we go. So now we have an easy output, nice to digest, one value, and we've answered our question. All right, let's move on to the next one. All right, so we haven't done this yet. We've either done pull all the columns or we've just done a single column. Now, if you want to pull more than one column to segregate them, you have to use a comma. And depending on whose code you're looking at, you might see commas in different places. You might see a comma up here, and then column name, or my habit is usually to put the column down here, but it doesn't matter as long as you have a column separating them. Again, SQL is very forgiving on your formatting and stuff. Yes, could we get a list of those helper functions so there's a question here, could we get a list of those helper functions such as count, lookup, and other arithmetic operations or operations within the text? Yes, I can put that in our reference slide when I send this out. There, another thing that you could do is just go SQL Snowflake documentation aggregate function list. Here, this will give you it. And then, yeah, within the Snowflake documentation, remember in class one, we showed that this is where it's going to have a lot of really good data if you're trying to learn something. So there's a lot here. Like I'm looking at this list on the side. I probably have used all of these at some point in time. They all have their use cases, but I'll tell you that average, count, max, median, min. Um, there are going to be these 5 or 6 that you use 80% of the time. And then as you're getting better and learning, hey, I want to actually look at the 90th percentile of this data set, then you can just Google or use ChatGPT how to do that. And yeah, you'll learn one by one, but just learning the sum count, we'll go through the very basic ones today. All right, next, how many wallets or users minted? So again, we're going to use the count. We want to count how many wallets. These are wallet addresses. So what is that? And if you didn't know any better, you'd probably be like, I don't know which one to use. And that's where you would go to the documentation, DBT docs, where they label details for each one. For the sake of time, I'm going to inform you that it's NFT to address. So this is the to address that the minted NFT got sent to. So if we do that as total minters, all right, I'm going to run this and we'll see what it does. Okay, that doesn't look right. That would mean that there's a unique person minting every one, but in reality, someone could have minted 10. And that's where we want to use distinct. So we want to know how many unique NFT addresses. So we'll use count distinct NFT2 address, and this will tell us the total unique minters. There we go. So we see that there was 986 wallets or users that minted 8,888. Perfect. We've answered that question using this count. What is next? How much ETH revenue is generated from the mint? All right, let's look back at our table and see where can we pull that data from. Let's see here. Um, mint price ETH. All right, let's do this. So we know that for each mint, there's a mint price. And so if we total up every single mint and their price, we should get the total amount uh, of ETH that was spent to mint. I'm sorry, that was a little confusing. Let me rephrase that. So when you purchase something, when you mint something on a blockchain, you have to send ETH to be able to buy it. So it's a transaction. And so here we have for each mint or purchase, there was a price that someone paid, and they sent that ETH over. So if we sum up how much ETH was sent over, then ideally we should get how much ETH was raised from the mint. So instead of using count here, where count is just counting how many of these values existed, we're using sum. So we want to sum up the ETH value from each mint. So hopefully that makes sense. And then we'll do ETH price as ETH revenue. All right. There we go. Okay, so it looks like 266 ETH was raised. Perfect. And that's in an ETH value. What if we also want to know the USD value? Well, let's do the same thing. I'm just going to copy paste this for simplicity. And instead of mint ETH price, I'm going to use mint price USD. This one. And run it. Oh, okay. So there's an error here. I copy pasted this. Yeah, even I make this mistake. I didn't change the name. So it had two columns with the same name. Oh, something's wrong here. We can't have that. So we'll change this to USD revenue. So an artifact of trying to speed things up actually slow things down. All right, wow. So we saw almost a little over 500,000 USD raised during that mint. It's pretty good. All right, last question is how much transaction fees were paid? So when you mint something, you have to pay gas to make the transaction occur on the Ethereum blockchain. So let's look at that. We're gonna do the same thing. We want to sum up how much fees were paid for each mint. And let's see where we could find that. Here we go, transaction fee. All right. All right, and this is an ETH, so I should have named this better, ETH transaction costs. But if you saw what that answer was there, they actually paid almost 3 times more in just gas costs to mint than what they actually paid the NFT project for the NFT itself. So people were paying more in gas than they were for um, kind of crazy to think about. But yeah, that's the artifact of um, the gas wars that occurred. All right. Let me know if you have any questions. Hopefully that made sense using these count and sum features. I'm going to use another example where we're going to go in a little bit more detail on them. But yeah, hopefully that makes sense. And if you do still have questions on how to use them, I'll put some reference material here. Yeah. All right, let's keep moving for the sake of time. Excuse me 1 second, I got a cough. All right. Yeah, someone asked, can you put the full query here in the chat? Yes, I believe these are saved. Oh, like the full text. Okay. Yeah, someone was already on top of it. Yeah, I'm gonna have these saved and sent out as well. But yes, looks like someone already got it. Awesome. All right, let's look at what's next. All right, so we've learned how to use these aggregate functions by summing up a full table. We're going to take it to the next step. And this is where I use aggregate functions probably the most. And this is where you're really going to start to see some really cool tables that you can build and stuff like that. All right, so what we're doing here is, and for the sake of time, I'm not going to type this out, but I'm going to run through what this example is, hey, we want to look at, we know all these tokens were minted. How many were minted per day? So look at one day at a time and tell me how many transactions, how many mints occurred on that day. And what we're doing here is we're saying select, and then we're using the block timestamp. So when something is minted, it has a time that it occurred, and that's solidified on this block timestamp. And what this function here is you'll learn to use this quite a bit. It's just a function to help you work with timestamps. So all I'm saying is date trunc. Show me just the day from this block timestamp. So if this timestamp occurred at 2021 7/22 at 1 in the morning with 30 seconds, I don't care about the 1 in the morning. I just want to know the day. So this is just saying, hey, get rid of all this more minor detail and just show me the day that it occurred. And then what I'm doing here is using this aggregate function of saying count the number of token IDs for that day. So if there were 10 days, it would count the token IDs where the matching block stamps were on that day. And so running through this example, and if I run it, they actually all occurred in one day. So we see all of them occurred in one day. Sorry, I'm going a little faster because I'm not typing it out. I realize I missed something. So in order to make this work, you have to put a group by statement when you want to say count these in relation to something else. So if you'll see in example one, we just did count these in relation to nothing. We just wanted to know the total. We didn't say count these on this day or count these from this user. It was all not based on any group by. And in this example, we do want to say, hey, count these tokens, but break them up by day. So what we do is we group by date. And again, here you can type out what that column is, or you can put column one. It will have the same result. Um, I default to using just one, whatever column it is, because it's quicker, but it might be more clear learning out that I'm saying group by this column. So let's play with this a little bit. Okay, they were all minted on the same day. Okay, that's good info. Really not that interesting though. Let's break it up even more. Let's say, break it up by hour. So now I want to know every hour, show me the total number, the count of tokens that were minted. And then we could rename this to mints per hour. Let's see what we get. All right, so it looks like within a 3 hour time span, all the NFTs were minted. And actually, it looks like they had a test mint where they minted the first one like 7 hours before the actual mint opened. And then within this hour, 60 were minted, and the next hour, the rest were minted. So that's pretty interesting. We see that it occurred pretty fast, but I want to know even more detail. Let's go minute, mints per minute. All right, this is more interesting. And just like Excel, I'm sorting here by hitting this column. What we learned is you can also sort by within the code. So I want to sort by the day descending. That'll give me the same thing as me clicking that column, but it'll spit it out that way. Oh, I didn't put order by, I just put order. Getting lazy. All right, there we go. All right, so you can see it ordered this date here automatically for me. All right, so yeah, we basically have a breakdown by hour, by minute. This is pretty interesting data. And this is data where you can then start graphing and start really looking at it. So again, the end goal here is we're analyzing something. We want to build an output that's easy to digest. A lot of times it's not you digesting it, so you need to make it as simple as possible. You will hear the term KISS very frequently. Stands for keep it simple, stupid, or silly, whatever you want to call it. That should be in your framework every time you're building an output visual. So in this case, we're going to use Flipside's data visualization side of it. So we've worked on the code, we built this really nice table. But if I showed someone this table, they gotta look at the minute. It's not really clear what the trend is. The numbers jumping all around. This takes too long for me to digest. So let's use a visualization. And this is where you can get really creative and really test different things. Do I want to use a line chart? Do I want to use a bar chart, a donut chart? Now, I won't go too much into the theory on what type of visuals to use. I think that's a very interesting aspect, and maybe don't worry too much on it right now. But I will say, if it's a time-dependent analysis here, usually a bar chart, line chart, something like that is really beneficial to get a quick visualization of what's occurring. Here, I'm going to use a bar chart, and let's make this big so we can show you how to make this. All right, I'm going to say NFT mints over time. And this is the title, let's capitalize. Okay, what do we want the X column to be? X, I usually go with the timestamp series. So we're gonna do date, and then the Y is gonna be mints per minute. Boom. This is way more easy to just take a glance at, visualize. It's a pretty even distribution. There wasn't a slow mint and then it ramped up at the end. So demand was pretty consistent throughout. A lot easier to digest. And then the final step is we build this query, we build this nice visualization. Now we want to put it on what we're calling a dashboard. And what a dashboard is really where you can take all your outputs. So if you do a couple different queries, you can put it all in one location. And then you can send that dashboard to people and they can view your outputs really quick, really easy. So let's go ahead and do that. So I'm going to add to a dashboard and I'm going to create a new, and there we go. Now it's sitting here. It's got a nice title. It's got the axes, and it's got the data. You can hover over it and see the values, and you can make it bigger. You can make it smaller. Yeah, so just showing you how you can take your data and put it somewhere finally. And then once you like what you have, you can ultimately publish your dashboard. And what this means is it's now available for, you can share it with other people. They can now see it. So if you want to work on yours on your own and not make it public yet, that's the final button you want to push here. All right, dashboard there. Cool. And then they got the share feature, copy URL. Let's see if anyone else can see that. Put it in the chat if you guys want to go there. All right. Let's go back to examples. All right. 3 minutes left in the reserved time. I'm going to just keep teaching for the sake of the recording. I know everybody has a really busy schedule. If you gotta jump off, no worries at all. What I'm gonna run through next is a little bit more of how to use ChatGPT to help you learn faster. If you have a question, how to phrase it. Basically, this rest of this is really going to be a little bit more of like what I do to help myself program faster. So it'll be on the recording if you got to jump off. If not, feel free to hang out with me for another 15 minutes probably here. And I'll just kind of answer some questions and go through this stuff in more detail. But before I do that, 2 minutes left on the initial block time. Anybody have any final questions? All right, we have a question here. When updating my data analysis, what assumptions can I write down, such as data sources from DeFi Llama, CoinMarketCap, how up to date it is? Yeah, I think it is an extremely good habit to document your assumptions and your data sources. And it's going to be case by case on how up to date it is. I think using reputable sources like the one you've listed here, I found to have very high quality data. It's when you're using new providers that there's a little bit of trust that needs to be built there. But I would say just start by writing down all of your assumptions that you can think of, and then you can refine it from there. I'm trying to think of unique assumptions that I write down. I would say there's assumptions on your data sources. Then there's also assumptions on your approach to an analysis that I find I spend a lot of time writing assumptions on. Okay, yeah, a good question. What sources are being used in the current workshop model? Awesome. So the sources I'm using is Flipside's custom models for NFT mints. So we went to this DVT documentation. We could go here and let's see. Here we go. So you can actually look at the source code that they're using to build out this model. And you can you look at where they're pulling data from. I know Flipside has their own data pipeline directly from the blockchain. Um, I have a lot of confidence in what Flipside's data is, but again, you can never be fully confident. I would say if you have questions about the data source and the integrity of it, just go into the Flipside Discord and asking questions there. Because if you don't know kind of sort of how to read this model code, it might be difficult. But you know, in short, we're seeing on the left here is like, okay, they built this out. Here's sources that they're using to pull data, um, and then here's the code that's being used. So it looks like they're pulling this from the silver NFT mints, so then you'd have to go find silver NFT mints. So you kind of gotta really dig deep into the code to fully understand it. And it's definitely a trust but verify, but you don't have the time to be, understanding all of their code all the time. So a lot of times what you do is you just do sort of some quick tests to validate the data on your end. Like we saw the NFT mints, there were 8,888. If I go check the Pudgy Penguin collection, there should be that many. Okay, that looks like a valid data set that I'm using. Right here, items 8,888. So that's just a quick check validation of the data that we're pulling from. All right, where is the add to dashboard button? Yeah, let me run back to that. All right, so if you pull up this add chart down here, after you click bar chart, this button here, it's kind of small on this top right, add to dashboard. That's the one you need. All right, cool. And yeah, it's been a while since I've looked at Flipside's model documentation, so definitely recommend. Zook might know more than me. Other people in the Metrics Now Discord and Flipside might know more. So if you really do have questions on this, yeah, go for the team. They're awesome at answering this. They're the ones who built it. All right, let's jump to using AI. Why not? Saves us time. Um, yeah. So what I'm thinking here is sometimes I'll have a question, and if you just ask ChatGPT, you know, how do I find NFT mints? Or how do I, you can ask it a really generic question and you got to give it more detail. And I want to run through an example on the information I provided that I feel like gives me really good results. So let's say we wanted to calculate the total NFT mints for each user. And let me just create a new one so it's not confusing. New chat. Okay. So that's our core question we have. Like, hey, there were 8,000 NFTs minted. How much did each user mint? I'm kind of learning. I don't really know how to do this. I need another example. Maybe ChatGPT can help me out here. So, Flipside uses Snowflake SQL. There's a lot of different types of SQL engines that have different syntaxes. So, I love to start by saying using Snowflake SQL. That way, it knows the specific documentation to look at and the syntax to use. Then I say my question. I say how to calculate the total NFTs minted for each user. Okay, if I just provided it that, it would still not have enough information. So I want to keep providing it information. So I'm saying for this contract address, and this is the Pudgy Penguin contract address. So let's start with that. Let's see what it gives us. Maybe I got to rephrase it. Maybe I don't. All right, let's see. All right, this looks pretty good, and it's really just a place to start. Let me get rid of this. So I don't know if this is right or wrong. I'm new, I'm learning, I'm not sure. Let's hit run. Let's see if it works. Nope. Okay, error. NFT mint transactions does not exist. Okay, so this table doesn't exist. Okay, that makes sense. So there's things ChatGPT doesn't know. It doesn't know what table you're pulling from, and it doesn't know the column names. So it's making assumptions based on the information you provided it. So in general, just telling you guys, this is formatted extremely well. This has the aggregate function that you need. It has the right columns that you need. It's just all named wrong. So usually when you're using ChatGPT, it's going to give you pretty close to the right answers, but you're going to have to change some things. So for starters, let's change the table that we're pulling from. Okay, that's changed now. Let's look at the other column names that it gave us. User address. Okay, we know there's no user address here. There's NFT address, but what we want to know is the NFT2 address is the user address. So we can put that in there, and we can put that down there, because we want to group by that. And I'm going to organize this a little bit more to the way I have it. All right. Okay. Oops, user. All right. All right. Let's try running this. Did I fix everything? Nope, I didn't. Okay, so contract address. Oh, this one's named different as well. So it's called NFT address in our table. Let's toss that one there. All right, and then the last thing I'm missing, I don't know if anyone spotted it yet, but again, just let's safeguard ourselves. Let's make this lower. There we go. All right. Oh, I'm missing another one. NFT count. So again, this is a column name that ChatGPT had to guess on. Incorrect. We want token ID. All right. So what's this query doing? It's saying, hey, for every unique minter address, show me the total token IDs that were minted. So that should answer our question. And then we got to group by this NFT address since we're using the sum. All right. Let's see how much each user minted. All right. That does not look right. NFT2 address. What are we missing here? So we are saying our NFT address equals that. That's a lot. Oh, we're summing. Yeah. Okay. Looks like everyone in the chat got it. So I'm actually surprised here that ChatGPT got this wrong. So it was using a sum function instead of count. We don't want to sum token IDs. These are unique numbers that adding them up does nothing. We want to count. So I'm actually a little disappointed in ChatGPT here, and maybe it was my wording. Maybe it was calculate the total NFTs minted. So yeah, maybe it was thinking that NFT count was like a number and not the ID. I think I asked this earlier, and I asked the exact same question. It did give me count. So there are some variations. It's not perfect, but I'll tell you, I use it all the time, and it is extremely helpful, especially with syntax things. So always start with using Snowflake SQL, ask it a question, and then just test a couple things. Provide it as much information as you can. All right, what do we get? So yeah, that's pretty interesting. So this wallet minted 141 of them. If they still held all of those at a 10 each floor, they would be a very wealthy person. Yeah. All right, I think that covered for the most part what we wanted to run through, and I think I've hammered enough tests using ChatGPT. I promise you it will save you a lot of time. And also, again, want to reiterate running through these aggregate functions, this sum, count, stuff like that. This is very core to what you'll be doing moving forward and is very well documented within SQL documentation. So I recommend, if it's still a little confusing, go read a little bit about that. Um, Not to discourage anyone, but usually the SQL is the easier part to analyzing Web3 data and analyzing um, finding the right information is the hard part. Like finding the smart contracts, knowing to use this table, understanding what all these column names mean and which one to pull. That's the stuff that sort of it's gonna take a little bit of a time of like reading documentation and stuff like that. So um, yeah, just again, you got to read the documentation. But any questions? Anyone confused about anything that I went over? All right. If not, I probably should have run through this before half the class jumped off, but I'll send it in the Discord. We do have a homework quiz. Um, this is our first kind of chance to start diving into what we've learned so far, and it's almost identical to what we ran through. So if you have the recording, you should be able to answer all these. Asking, hey, which table do we use? What does this column mean? Well, now you guys have seen the answers. Oh well. Yeah, more details about just stuff you'd have to look into the documentation for to get you familiar with knowing that you need to read the documentation. And then finally, yeah, instead of looking at pudgy penguins, we're going to look at moonbirds, which is another NFT collection. So it should be very, very similar with just different results. So we'll have you run some things, get some answers, and then not required, but everything that you built at the end, if you add it all on a dashboard, fantastic. You're a leg above everybody else. Um, cool. I'll send this out via email. Also send out in the Discord, and within 24 hours, get the recording out as well. Yeah, I missed some of the early questions, so if I missed anything, let me know. Seen a lot of people doing some really good work already diving into some queries. If you haven't, don't worry, those people have been above and beyond. This was our first time actually showing you guys how to pull data. So um, this should be your first time really diving in for most of the class. Cool. I'll end it there. Office hours, Thursday, same time. Come hang out. Honestly, last office hours we had a good group and um, just kind of talked a little bit. People asked a little bit more about background and just about the industry, and yeah, I got to know some people a little bit more. So come hang out. You don't even have to have questions. Just hang out to learn if you can make it. All right, everyone. I appreciate your time. Enjoy the rest of your day or evening. We'll see everybody. Oh, we got one last question, maybe. Saw a hand go up. Anyways, all right. We'll see you guys.